Alright, so pulled the service manual down. I unfortunately cannot do the FM alignment. I need some additional equipment that I don't have, so we'll do the amplifier section alignment. So we're going from test point 1, and we're going to adjust VR406. Alright, so test point 1 was kind of tricky to find. If you can see, it's a little tiny test point right above the that big white resistor right there, and test point 2 is on the other side. Not sure if you can see test point 2 right there, right next to that cap underneath that gold. I assume that's a cap. I don't know what that is. So anyway, so one side's to ground, the other side's to test point 1, and then VR406 is right there, and I will be adjusting that. But it says to adjust to 0 within plus or minus 100, right? So it says observe left and right channels on the digital multimeter at the same time, which I guess I have to grab my other multimeter, and then set to the point that DC offsets of both channels are at minimum less than 0 plus or minus 100. So that's like a pretty wide. That's a pretty wide range. So let me grab another voltmeter and throw it on there and see what's going on here. All right, so I'm not sure if you can make that out over here, but we've got negative 33 on, and I'm not sure which is right or left. Negative 30. No, we have 33 millivolts here. We have negative 264 here. That's kind of crazy. So let's see what kind of adjustment we can make to that pot. See if we can get that to calm down a little bit. Plus or minus 100. So we might end up dialing one into 100 and the other one into minus 100. I'm just kind of curious as to what we can do here. Get them balanced. Oh, so we're going to be at around around 80. Maybe a little under 80. It's kind of touchy. Might be like 81, 82. Negative 80 and 82. Man, that's wild. I mean, I've never seen a are at minimum. So they're at minimum. They're within the range. I don't know that I like that, but gosh, plus or minus 100. That's crazy. All right, so offsets of both channel changes. So set the left and right channel so there's a balance of the two. It says that is best. Okay, so idle current adjustment. Now we're going to do each channel. We're going for 6 millivolts plus or minus 3, and we're going to have to go from test point 1 to test point 2. Test point 2 is really precariously positioned in there, especially on this board because there's a capacitor that is right, that's kind of bent into, it's kind of in the way to access the test point. So I'm going to do this channel first, and then I'll come back and I may have to turn it off and then move that capacitor and then hit that second test point. And the DC offset keeps going up on these channels. So I know these run hot. I know these are known to run hot, so I have to keep an eye on that. I may just let this run for about 20 minutes and see what happens. But let me do this idle current next, and let's see. If I do something stupid, I'm going to catch it. Gosh, that one's pretty close too. What I don't want to do is touch that capacitor in the test point lead. Okay, so we've got 5 millivolts on that channel, and I think I'm good with that. I think I'm good with 5 millivolts there. It says 6 plus or minus 3. It's within that range. So I'm going to power this off, and then I will come back, and I'm going to set this channel, and then what I'm going to do is let this run for a while and see what happens with that DC offset, and see if I can, because I think it's going to go over 100, but it says to let it warm up for 5 minutes. But I would think that you would want to have that stable. I mean, yeah, but I am totally not familiar with this amplifier at all. So let's kill power, reposition that cap. Yep, and that's discharging. I can't move the cap, so I'm gonna have to I'll quit beeping. Alright, so let me fart around with this for a little bit and I'll come back. Alright, it's been about 10 minutes, and the DC offset keeps fluctuating up and down a little bit here and there. And it's slowly creeping up to that 100 millivolts. So just want to zap this, see what kind of heat this is. I know there was a service bulletin on the R1000 and the R2000 to help with, I think it was to help with some of the heat issues, but I cannot find them. So the outputs aren't getting hot. That is getting hot. It's 120. The DC offset just keeps going up though. So I can't get it to, I'm trying to just kind of get it to stabilize. I want to see where it kind of evens out, or if it's just going to keep rising and rising and rising and rising. So I'm going to let it keep running. It's, I don't know, I'm going to give it maybe another 15 minutes or so, come back and check it again and see what's going on with it. Okay, it's been about 35 minutes. And I'm going to see where we're at so long that my meters shut themselves off. So after 35 minutes, we're at 100, negative 111 and 102. Bring this down a little bit. And, you know, I'm going to have to look at the service manual, the schematic, and look at this circuit. And I may put a post out on Audio Karma, talk to some of the Yamaha experts, and just kind of learn about this circuit and how it works, and maybe some contributors to that high DC offset. Because it's not horrible. I mean, we're talking about plus or minus 100, but we're definitely beyond, right, the range. And, you know, ideally you want this as close to 0 as possible, but it does give us like a wide kind of range in terms of value there. So anyway, I think I'm going to do that. I'm going to I don't know, probably button this up for now and see what they have to say about that circuit, and I may just look at the service manual and start poking around and seeing what I can find in terms of maybe some potential issues or components that would affect that DC offset. So, yep, so I'll check back in when I find something out about this, and if this is the last you see of this, then as always, if you like what you see, hit subscribe, and I'll catch you in the next video. Okay, it's been about a week since I have, since I stopped working on the Yamaha. I think I've found a solution to the DC offset, and it's very interesting. So I posted out on Audio Karma. This is one of those pieces of gear where there just aren't a lot of people that know a lot about it. So what I found was, so in the last segment, I was getting 100 millivolts, slowly creeping up. After 40 minutes, I was kind of topping out at about 140 millivolts. This heatsink was getting extremely warm. So one of the things that I saw out on some of the boards, Audio Karma basically, was that you can attach a separate heatsink to this to bring the temp down. So what I did is I grabbed from an old PC a heatsink, and I just have it kind of wired in here, right? The wire's not making contact with anything that it can short. So it's wired in here. I also have a zip tie. This gets to about 140 degrees. The zip tie shouldn't melt, right? But it may get brittle after a while, so I reinforced it with a piece of wire, and it's not budging. It's not going anywhere. So anyway, so now with this heatsink attached, it stabilizes at about 70 millivolts. So the range is 0 to 100. The interesting thing is once you apply a load and you turn up the volume, that DC offset drops. So if I apply a little bit of volume to it, it'll kind of stabilize. I thought it was stabilizing around 30, but it'll stabilize around somewhere between 40 and 50. Is that how this amp works? I have no idea. And others did not have any idea. So I think I have the heat and the DC offset figured out. I've also been experiencing some intermittent connectivity issues. Again, I'm an IT guy, right? Some intermittent channel dropout when I attach speakers to the A speaker terminals. And I want to show you, like on a lot of Yamahas, see if I can zoom this in and show you what the issue is. So let's zoom in, and we're going to look at the speaker terminals. Do you see a problem with the A speaker terminals there? Now watch when I turn this black knob, see how that closes? See how this closes? We should not have a broken solder joint there. So I think because these are the primary speaker connections, right, that over time that solder joint has broken. So if you're having, and this goes for Yamaha, I would imagine Techniques, because they use the same kind of speaker terminal connection, right, where it's this little plastic sleeve there. Make sure you first check the solder joints, right, for the bottom of those terminals, and reflow some solder to them. In fact, I would hit all of these because I see a crack in this one, and I see a crack in the next one, and I see a crack in this one. I don't see any issues with these two, but I'm going to hit them anyway. There's no crack there. So these two look good. So, all right. So I reflowed solder to all of those. All right. So now I should not have an issue when connecting speakers to the A speaker terminals. So I'm going to test that, because before it wouldn't even, I mean, like I had to monkey with it and do a bunch of crazy stuff. So if this just pops in there, locks in, and I get sound, I'm going to call it good, because it would not do that before. Also, So here's what's interesting about this receiver. If you are running more than one set of speakers per the little legend on the back of this, they have to be 16 ohms. So if you're assuming, hey, I've got a pair of 8 ohm speakers and I can run, you know, A and B together, according to the back of this, you cannot. So you want to make sure that you pay attention to that. So let's fire this up. Got it on A, and it's on FM. And I have a station. Well, station's not really tuned in. Let me get an antenna on this and get some sound going. Okay, so
thank you so much.
Got sound.
Oh, we get to do it all.
And again,
That's right. Oh, by the way, answer.
just some people talking there. And again, I can tug on, and it was this left one that was really bad.
On the iHeartRadio app.
Can tug on that and no issues. No issues there. All right. So I'm going to say that the Yamaha R2000 is done. So that is exciting. We can get this to the shop. Cool receiver. I was considering it, but I have to stop considering keeping things. That is an occupational hazard with this hobby. Let me tell you, it is, I mean, you've only seen some of the stuff that's come across my bench. And like I mentioned in an earlier video, like, hey, what happened to the video on, you know, that thing that was in your project preview? You know, not everything that that comes in I do a video on, because sometimes it's perfectly fine, and sometimes I've worked on a couple of them. There's no sense in having 3 or 4 videos on the same piece of gear. And then a lot of times I don't, you know, if I get onesie, twosie pieces of equipment, I'm not going to do a project preview on it. So the example video, or yeah, was on a Pioneer SX950. Came in, another tech had worked on it. We know him. So I plugged it in, tested it, worked just fine. You know, why do a video on that if I'm not going to be completing some kind of work on it? I mean, I could do maybe the alignment procedure, but, you know, those can get kind of boring, I guess. And plus, you know, recording and editing it's more time consuming than you would think. So, and I only have so much time to work on stuff. So anyway, so you won't always see video on stuff that crosses my bench. And again, I get some really cool things, some interesting things that, you know, like, oh, you know, this R2000 is a pretty rare receiver. And I would only be keeping it because it's a pretty rare receiver. I gotta tighten that. So anyway, I'm just rambling at this point. So the Yamaha is done, all cleaned up, all adjusted. Got that intermittent speaker issue ironed out and the heat issue ironed out. So I'm satisfied with the work on this. So if you like what you see, hit like, hit subscribe, and I will catch you in the next video.